Hello everyone, welcome back from my channel. Today we are going to do the exercises from Cambridge Primary Science Workbook 5. 3.1 Gases. Focus. Look at the picture of a glass of soda. Number 1. Write the labels for solid, liquid, and gas in the correct places on the picture. Number 2. Use the words in the box to complete the sentences about the states of matter. Vinegar, oxygen, states, rock, particles. A. Solid, liquids, and gases are the three states of matter. B. All matter is made of tiny particles. C. Oxygen is an example of a gas. D. Rock is an example of a solid. E. Vinegar is an example of a liquid. Question 3. Air is a mixture of gases. Say why this is so. Air is a mixture of gases because it is made out of the gases nitrogen, oxygen, carbon dioxide, and water vapor. Practice. Question number 4. You have particles of matter. Draw the particles in each box below to represent a solid, a liquid, and a gas. Question 5. Fill in the table to describe how particles move in the different states of matter. States of matter. Do particles move a lot, quite a lot, or hardly at all? Do particles move apart, move far apart, or shake in one place? Solid, hardly move at all, shake in one place. Liquid, move quite a lot, move apart. Gas, move a lot, move far apart. Challenge. Look at the picture of particles in the two syringes, A and B. Question 6a. Which syringe do you think contains water and which syringe contains air? Syringe A contains water and syringe B contains air. Question B. Explain your answer using the particles model. In syringe A, there are many particles close together, but not as tightly packed as in a solid. In syringe B, there are fewer particles and they are far apart as they are in a gas. Question 7. If you hold your finger over the open end of the syringes, which plunger will be easier to push down? Use the particle model to explain why. The plunger of syringe B. There is a lot of space between the gas particles. When you push down the plunger, the particles can move into the empty spaces. This makes gases easier to compress. 3.2 Properties of water. Focus. Choose the correct answer to each of the questions. Draw a circle around the letter of the correct answer to each question. Number 1. Which process makes ice become liquid on a hot day? B. Melting. Question 2. Which answer shows the process of melting? C. Solids plus heat becomes liquid. Question 3. Which answer shows the process of boiling? C. Liquid plus heat becomes gas. Question 4. Which of the following does not happen when we freeze water? B. It contrasts. Question 5. Your teacher heats a pan of water. When the water temperature is, which point has the water reached? D. Boiling point. Practice. Aaron put a block of ice on the saucer. Question 6. Make a drawing to show the ice cube after A. 2 minutes, B. 10 minutes. Question 7a. What has happened to the ice? It has melted. Question B. Why did this process happen? It melted because the solid ice particles gain enough heat energy to escape from the solid and change into liquid water. Question 8a. At what temperature does this process start to happen? 0 degrees Celsius. Question B. What do we call this temperature? Melting point. Challenge. Sophia's class investigated boiling. These are their results. Question 9. What do we call the temperature at which a liquid boils? Boiling point. Question 10a. Which liquid boils at the highest temperature? Milk. Question B. At what temperature does pure water boil? 100 degrees Celsius. Question 11a. Does water always boil at the same temperature? How do you know this? No, the tap water, salty water, and sugar water boil at a different temperature to pure water. B. Use the results to suggest a reason for this. When we add other substances to water, such as salt, it changes the boiling point of the water. Question 12. Why can you cook a hard-boiled egg on Mount Everest? You may have to do some research to find out. On Mount Everest, water boils at about 70 degrees Celsius. Egg yolks cook hard at 65 degrees Celsius, but egg whites must reach 85 degrees Celsius before they become hard. So, the egg yolk will cook on Mount Everest, but not the egg white. 3x3 Evaporation and condensation. Focus. Question number 1. Underline the correct words to complete the sentences. Evaporation occurs when a liquid changes into a gas. This happens because the particles gain heat and move faster and further apart until some of them escape from the surface and become a gas. The opposite process to evaporation is condensation. Question number 2. Decide if these sentences are true or false. Mark each one as either true or false. A. Evaporation makes wet clothes dry. True. B. Water disappears when it evaporates. False. C. Condensation occurs when a gas changes to a liquid. True. D. Heat makes condensation happen faster. False. E. Particles must lose energy before they can condense. True. Practice. Sarah left some cool drink in a bottle on a windowsill. The next day, she opened the bottle and saw that the inside of the lid was wet and there were droplets on the inside of the bottle. Question 3. What liquid formed inside the lid and inside the bottle? Water. Question 4. Where did the liquid come from? From the cold drink. Question 5. Name the process that made the liquid from inside the lid. Condensation. Question 6. Explain how this process made the liquid form. Some particles of water in the drink evaporated. When the particles touched the sides of the bottle and the inside of the lid, they cooled down and became liquid again. Question 7a. Which process is a reverse of the process you named in question number 5? Evaporation. Question B. Would the drops of liquid have formed without the reverse process? Say why or why not. No, the water particles would have stayed in the solution or cool drink. The particles needed to evaporate into water vapor and then cool to form the water droplets inside the bottle and lid. Challenge. Marcus and Aaron investigated the evaporation of water. They placed 2 containers of water on the windowsill. Question A. Draw a graph of the results for each container of water. Think about the type of graph you should draw. So, this is a result of the graph for each container of water. The blue color means container A and the purple color means container B. Question 9a. From which container did most water evaporate? Explain how you know this. Most water from container B evaporate because there was less water left in the container at the end of the investigation. Question B. Why do you think more water evaporated from that container? Container B had a larger open surface than container A, so more water vapor particles could escape from it. Question 10. Predict the results if Marcus and Aaron continue their investigation for another 2 days. Fill in your prediction in the table and add the new points to your graph in another color. So I predict that for the next day in the container it will be 130 milliliter and 100 milliliter, and for the container B 50 milliliter and 20 milliliter. So this is the result of the graph for another 2 days. 3.4 Solutions. Focus. Question number 1. Aaron is writing a report on the investigation. Help him complete his report. Use the words in the box to help you. So the words are salt, solute, evaporating, solvent, warm, dissolve, evaporation, solution, water, evaporated. Aim, we wanted to find out if you can get salt back from a solution by evaporation. Method, we dissolved some salt in water in a beaker to make a salt solution. The salt was the solute and the water was the solvent. We left the beaker in a warm place for a few days. Results. After a few days, there was salt in the bottom of the container. There was no water. It had evaporated. Conclusion, we found that we can get salt back from a solution. We do this by evaporating the water. Practice. Sophia poured hot water into a glass. She added a teaspoon of coffee powder. She stirred the water. Question 2a. Make a drawing of the glass of water and coffee before Sophia stirred it. So this is a drawing of the glass of water and coffee before Sophia stirred it. Question 2b. Make a drawing of the glass of water and coffee after Sophia stirred it. So this is a drawing of the glass of water and coffee after Sophia stirred it. It became the solution. Question C. Write the labels solute, solvent, and solution on your drawings. So in the last drawing, we did already. Question 3. Explain what happened to the coffee powder when Sophia stirred the water. The solute coffee powder dissolved in the solvent water. The particles of coffee powder move in between the particles of water, so you cannot see them in the solution. Question 4. How can Sophia get the coffee powder back again? Sophia can get the coffee powder back by leaving the solution in one place until the water has evaporated. Challenge. Marcus put a teaspoonful of sugar into the glass of water to make a solution. He stirred the mixture. After a while, the sugar disappeared. Question 5. Where has the sugar gone? The sugar has dissolved. Question B. How can you test that the sugar is still there? We can taste the water. Question C. What part of a solution is the water? Water is the solvent. Question D. What part of a solution is a sugar? Sugar is a solute. Water and sugar are made out of many tiny particles. We can represent the particles of water and sugar in a model like this. The circle shapes are particles of water and the triangle shapes are the particles of sugar. Question 6. Use the particles model to draw a picture of the solution Marcus made. Label your particles. So this is a picture of the solution Marcus made. Question 7. Marcus added more and more sugar to the solution until no more sugar dissolved. Use the particle model to draw a picture of the solution. So this is a picture of the solution that Marcus added more and more sugar until no more sugar dissolved.